Welcome to the Angular Signals Masterclass. This video is your complete guide to modern Angular reactivity, moving from the basics to advanced production patterns. We'll cover core APIs like Signal, Computed, and Effect, Signal APIs such as Input and Model, and advanced topics like Resource and Linked Signal. This video will cover 12 key topics, starting with the problem Angular Signals solved. We will then dive into the core APIs and their usages, compare signals with RxJS, discuss signal-based components, and explore advanced topics like signal inputs, signal queries, signal forms, NGRX signal store, and resource for async data. The video concludes with interview Q&A covering all levels. Our first module asks, why signals? This topic addresses the problem Angular solved, specifically the pain points related to Zone.js, and introduces Angular's new approach to reactivity. This section is beginner-friendly, but also includes interview-ready and Angular 18+ concepts. Introduced signals to overcome limitations of the old Zone.js approach. Zone.js caused slow full-tree checks, increased bundle weight, and lacked precise tracking. The Signal way offers precise updates, enabling zone-free builds, and automatic dependency tracking for better performance and smaller bundles. Module 2 dives into Signal basics. Here, you'll learn how to create, read, write, and update reactive values efficiently. This is a foundational concept that sets the stage for understanding more complex Signal features. Signal is a reactive variable that Angular watches for changes, automatically updating the UI. You create it with Signal, initial value, and read it with count. Updates are handled via .set for full replacement, .update fn based on current value, or .mutate fn for in-place changes to objects or arrays. Module 3 covers Computed for derived state. This primitive is for values automatically calculated from other signals, updating instantly when its dependencies change. Computed tracks dependencies automatically, ensuring the value refreshes only when needed. It's memoized for instant return of cached results. It is read-only, preventing external manipulation. Most importantly, it must be pure, with no side effects, which should be handled by Effect. Module 4 introduces Effect for side effects. This allows you to run code automatically when signals change, handling tasks such as logging, storage updates, or DOM manipulation. Effect runs immediately on setup and whenever signals change. You can clean up resources using onCleanup. Effects must be registered in the constructor or ng onInit. Use allow signal rights, true only if you need to set signals inside an effect. Remember, effects are strictly for side effects, not deriving data. Here's a quick summary of the core primitives. Signal stores and manages state. Computed derives values from signals, like a formula. Effect runs side effects when signals change, such as logging or DOM manipulation. Use each for its specific purpose to maintain clean reactivity. Module 5 explores signals versus RxJS. These are not enemies, but two distinct tools. Understanding their differences is key to knowing when to use which in your Angular application. Signals are reactive variables with current values, always persistent, and use direct template syntax. Subscriptions are automatic. RxJS observables are streams of events, not always persistent, and require the async pipe in templates with manual subscription cleanup. Signals are best for local UI state, while RxJS is ideal for events and complex async orchestrations. You can use them together with toSignal and toObservable. Moving on to signal inputs in Module 7. This introduces Input and Model, which replace the traditional @input and @output decorators, offering reactive signals from the start for component communication. Input creates optional inputs with default values. Input.required enforces inputs, providing compile time errors if not supplied. Model streamlines two-way binding, replacing both @input and @output event emitter in a single declaration, simplifying component logic significantly. Module 8 covers signal queries, viewChild and ContentChild. Signal queries allow you to access child components and DOM elements as reactive signals. This provides significant advantages for setup timing and reactivity. ViewChild finds a single element, while ViewChildren finds all matches and returns a signal array. ViewChild.required throws an error if the element is missing. The big advantage is that signal queries are available immediately in the constructor via Effect. Module 9 introduces signal forms with linked signal. This function is like Computed in that it auto-calculates a value, but unlike Computed, linked signal is writable and can be overridden manually. This is perfect for dependent dropdowns and state that needs a reset mechanism. Signal calculates a default, but allows manual override, making it writable. This enables cascading dropdowns where the city resets when the country changes, but a user can still manually pick another city without breaking the reactivity. Module 10 presents the NGRX signal store for simple state management. This replaces much of the complexity of traditional NGRX by using signals for all state and plain functions for all methods. Signal store uses withState to define the initial state with computed for derived signals and with methods for state-changing actions. It also includes with hooks for lifecycle methods. This approach is much simpler to learn and use. Module 11 explores Resource for async data loading. Resource is Angular's built-in solution to load async data, automatically managing the loading, error, and data status as signals. Resource automatically gives you signals for .value, .isLoading, .error, and .status. A key feature is auto-refetching. When the request signal changes, Resource automatically triggers a new HTTP call.